In this video, we are going to have a look at how to use the Polynomial Root Finder in TI-84. Polynomial Root Finder is one of the applications in TI-84. In order to use this, we can try to press the Apps button and then scroll down until we can see the option called PLYSMLT2 and then press Enter. Here is the main menu. We can try to choose the first option, Polynomial Root Finder. Every time when we are going to solve the polynomial equation fx equals to 0, we will be able to have some settings here. For this video, we will have some examples related to quadratic equations and cubic equations. Let's say I'm going to solve the quadratic equation called x squared minus 8x plus 12 equals to 0. For this screen, order means the highest power of x. We will try to choose 2. And for the second row here, it means whether you would like to display the answers in terms of real numbers or complex numbers. The default will be usually real numbers. And similarly, for the next three called auto, normal, and float, those are just some default settings about the number presentations. And for the last row, it represents whether you would prefer using radian or degree to present the argument in complex numbers. As in AA high level and AI high level, radian measure would be one of the compulsory topics. Then for high level students, the default setting can be radian. Once we are done, we can try to press the graph button to represent that we are going to the next page. We try to press the graph button because this button is the closest to the notation next. Then this is the page for us to input the coefficients. As we are going to solve the quadratic equation called x squared minus 8x plus 12 equals to 0, which means the coefficients are 1, negative 8, and 12. So I will input positive 1 for the first box. And here you can choose either using plus or minus. In case if the next coefficient is negative, you can try to consider choosing minus here. We have two different ways to input the next coefficient. We can either change this symbol to minus, and then the next one we are going to input 8, or we can simply keep every symbol to be plus, and then we input negative 8 here. As we know that plus a negative number is equivalent to minus a positive number. And the constant term is positive 12, so I try to choose plus and then 12 here. Once everything is here, we can try to press the graph button again to solve this quadratic equation. Then from the summary here, we can see that the first answer is positive 2 and the second answer will be positive 6. Sometimes when you see that some of the answers are decimals or fractions, if you wish to have the interconversions, you will be able to press the graph button to do the interconversion. If you have quite a lot of the quadratic equations to solve, then you can try to press the zoom button to change the coefficients. And because my next example will be solving a cubic equation, which is a polynomial equation of the degree 3. Which implies that I have to change a little bit about the initial settings. Next, I will try to press the window button to go to the setting page. If I'm going to solve a cubic equation, then from the first row, the order should be changed to positive 3. Let's try to keep other things unchanged at this moment, and then press the graph button. Now we can see that there would be 4 boxes for us to input the coefficients. Let's say, for example, I want to solve the cubic equation called x to the power 3 minus x squared minus 9x plus 9 equals to 0. The first one is positive 1, where the second one would be minus 1. And then the third one would be minus 9. And the last one would be plus 9. And then we press the graph button. Then we can see that this cubic equation will give us 3 distinct solutions. And then our next 2 examples will be solving cubic equations as well. Then we can try to press the zoom button. to change the coefficients directly. This time I'm going to solve a new cubic equation called x to the power 3 minus 7x to the power 2 plus 15x minus 9 equals to 0. So similarly, the first coefficient will be positive 1, followed by negative 7, and then positive 15, and then minus 9, and then press the graph button. Then from this summary, we can see that there should be only two different solutions only, as we can see that the second answer and the third answer are the same. And then we can try to look at the last example about the another cubic equation. Press the zoom button again. This example will be especially important for AA higher level students. Let's say I'm going to solve the cubic equation called x to the power 3 minus x squared plus 4x minus 4 equals to 0. So again, input all the coefficients. Positive 1, followed by minus 1, followed by plus 4, and then the last constant term would be minus 4. And then press the graph button. From the summary, we can see that there's only one real solution. But from the concept of polynomials, the highest degree of a cubic equation would be positive 3, which means there should be 3 quotas for 3 different solutions, including real solutions as well as complex solutions. From this summary, we can see that there's only one real solution, which means there should be 2 other complex solutions. And if we wish to display the values of the 2 complex solutions, we can try to press the window button and then go to the second row. To display any complex number, we can try to choose the second option or the third option. So this time I'm going to choose the second option, which means if there are complex solutions, those solutions will be expressed in the form a plus bi. And then let's don't make any change for the other settings. And then press the graph button. Press one more time. Then we can see that we have x2 equals to positive 2i and x3 equals to negative 2i. And those two are the corresponding long real solutions or so-called complex solutions. We press the window button again and then go to the second row. And if we are going to choose the third option, which means we are going to present the complex solutions in Euler form, and then press the graph button for 2 times, then those 2 complex solutions are in Euler form, in which the arguments are measured in radian.